Okay, hey everybody. I'm hoping that I can keep this video relatively short for you all and help you learn how to take the second derivative of a parametric equation. Yesterday we found out how to get the first derivative, dy dx. So we knew we had dy dx for us is y prime of t over x prime of t. Well, to get the second derivative of and by the way, that was because, right, dy dt over dx dt. If I flip things around, I'd have dy dt dt dx, and the dt's could cancel out and give me dy dx. So to get to a second derivative, d2y over dx squared, the first thing I need to do is take the derivative of dy dx. But that's going to give me, I don't know if you can tell, that's going to give me d2y over dt times dx. So that's not what I need. I need d2y over dx squared. So to do that, what we have to do is we have to divide by dx dt again. And so we already have the first derivative of x, but we just divide by it a second time. The reason why is because that'll let us, dt dx here. That'll let me multiply by the reciprocal, so dt over dx. The dt's cancel, and look at that. We end up with d2y over dx times dx, or dx squared. So there it is. That's why this derivative is set up this way. We're going to take the derivative of the entire first derivative with respect to t, and then we're going to divide it by dx dt. If I wanted to get a third derivative, I'd do the same thing. I'd take the entire derivative of the second derivative, and then I'd divide it by dx dt. If I wanted to get a fourth derivative, I'd take the entire derivative of the third derivative and divide it by dx dt, et cetera, et cetera, et cetera, forever and ever and ever. So we saw yesterday, it's pretty easy to take derivatives of this stuff. X prime of t is 2t, y prime of t is 3t squared. So dy dx is equal to 3t squared over 2t, or 3 over 2t. So to get to the second derivative, that's going to be this one's derivative, which is just 3 halves, all over x prime of t, or 2t. So it ends up being 3 over 4t. Because this was on the AP exam, so that was an AP exam question. Like I said, parametric stuff is not that tough. It's actually pretty straightforward. It's just learning the mechanics of it. It's way easier than all that series stuff we just finished. Here's kind of an application sounding problem. Path of a particle is given for time t is greater than 0 by some parametric equations. Here they are. Find d2y over dx squared when y is equal to 12. Well, let's see. Well, when y is equal to 12, I also know that y is equal to 3t squared. That's going to let me know that this is happening when time could either be plus or minus 2. They told me, however, that time has to be greater than 0 in this case, so I'm only going to be dealing with time as 2 here. So when I'm thinking about what I'm plugging in, remember, I'm not plugging in an x and a y anymore, because those aren't the variables that I have access to, right? The variables I have access to are t in this case. So first I need to get dy dx. So to do that, I need an x prime of t, which is negative 2 over t squared. I need a y prime of t, and that would be 6t. So dy dx is equal to 6t over negative 2 divided by t squared, which is 6t cubed divided by negative 2, or negative 3t cubed. To get to the second derivative, I'm going to take the derivative of that entire thing, which would be negative 9t squared, and divide it by x prime of t, which is negative 2 over t squared. This ends up giving me positive 9 halves t to the fourth. I put 2 in for t, and so I can say the d2y over dx x squared evaluated when time is equal to 2 is equal to 9/2 times 2 to the 4th power, or 9/2 times 16, or 72. Okay, this is just kind of a brief look at taking a second derivative. It's really just this one kind of extra step in here that people tend to forget. I hope it makes sense. Hope you're all having a good day, and I will see you all in class soon.